Hello. Today we're going to be talking about evaluating the limit of a function using the limit definition of the derivative. Remember, the limit definition of the derivative is and so what we want to do, let's make sure this is a 0. We want to take the derivative of the function f of x equals the square root of x plus 1. So in order to evaluate the limit, I'm first going to focus on simplifying this, what's called the difference quotient. Now to simplify this, I'm going to do this in 3 steps and then hit it with the limit. So the first step I'm going to do is I want to find f of x plus h. F of x plus h means wherever I see an x, I'm going to replace it with an x plus h. So that's going to be the square root of x plus h plus 1. Next, I want to look at f of x plus h minus f of x. And that equals the square root of x plus h plus 1 minus the square root of x plus 1. And in fact, I can't simplify that any further. So I'm just going to leave it like that and move on to my next thing I want to do, which is simplify f of x plus h minus f of x all over h. Now, you may have been told in class that your ultimate goal is to get h out of the denominator. Well, if we look at the difference quotient, we get the square root of x plus h plus 1 minus the square root of x plus 1. This is all over h. And what you should notice here is that we can't get to this h because the square root is there. So the method we're going to do to get to this h is called multiply by the conjugate. So I want to remind you of something, that if I were to look at the square root of a plus the square root of b times the square root of a minus the square root of b, this equals a minus b. Again, provided a is greater than or equal to 0 and b is greater than or equal to 0. So I want to use this idea. I have a square root of a minus the square root of b. So I want to multiply by the conjugate to the top and bottom. So that is, I'm going to multiply by the square root of x plus h plus 1 plus the square root of x plus 1 to the top and bottom. Okay? So the top is going to simplify with no radicals. But the bottom, I'm just going to leave the h on the outside. I'm not going to distribute it. So I'm going to move it right here. The top is going to become x plus h plus 1 minus x plus 1. And if you don't believe that, I challenge you to do this product. Expand that out, and you should see that this is the result. Then I divide this by h times the square root of x plus h plus 1 plus the square root of x plus 1. Okay? And then what you should notice here is we have x minus x, so that goes away. And we have 1 minus 1, so that's going to go away. And as a result, I am left with only an h on top. So we have only an h on top, and it's positive. And then divided by h times the square root of x plus h plus 1 plus the square root of x plus 1. And then what we see here is that the h's cancel. So I'm going to cancel the h's. And I am left with this is, you can pay attention, I'm left with 1 over the square root of x plus h plus 1 plus the square root of x plus 1. So one thing to pay attention to, that once I cancel out these h's on the top and bottom, I still have a 1 on top. Then I have the bottom. Notice why I didn't distribute the h when we were at this step here, because we saw that the h's are going to cancel, and it was very clear that they cancel. Okay, so now I have a reduced quotient, difference quotient. So I have this is reduced. Now I can hit it with the limit to clearly evaluate this. So I'm going to look at f prime of x equals the limit as h goes to 0. And we have f of x plus h minus f of x all over h equals 1 over the square root of x plus h plus 1 plus the square root of x plus 1. And so now I can evaluate this limit. I'm going to replace all the h's with 0. So that's going to be 1 over the square root of x plus 0 plus 1 plus the square root of x plus 1. And so what we should notice is we have a square root of x plus 1 and another square root of x plus 1. So this becomes 1 over the square, 2 times the square root of x plus 1. And so that is the derivative of this function.